Okay, I think I'm live. Yeah, so that's great news. Yes. Now, listen. First of all, thank you guys for a lot of subscribers. There's actually 108 subscribers. That's a lot. I love that. So that's awesome. Let's upgrade the counter. Now, second, I've been thinking about the code, and I think that the quality is okay. However, the design is shit. So today we'll compute like a design work. I guess we will code for like an hour maybe. I've been coding today, and what I have achieved is that I have cleaned up this messy code. Mm, we don't have the observer here. I think that's a wrong path to take. When I kind of like laid it out how I want the server to work, I think the observer is something that is just not necessarily correct. Now, I added this public connection structure that encapsulates WebSocket and state because we are passing it in like 100 different places. And when you pass two parameters of the same type in 100 different places, you probably need the structure. So I call it connection, and now we have really nice structure, nice function that will get to interface with that. Now I also have coded this TSQ, which is thread safe queue. I don't really know how to call those thread safe structures, so I just replace them with TS. Actually, we'll commit because I want to have a clean slate. A lot of changes. This queue server. Yeah, let's push it. So there's a bunch of changes, and this TSQ is cool. As you can see, it takes in template parameter as a concept. This template parameter basically must be copyable and can throw when copied. And there's also this interesting if const expression here. That is an immediate lambda invocation, something like that. Immediate lambda invocation. Lambda expression immediate invocation, something like that. I don't really understand. I don't remember the acronym for this idiom. However, it's cool because for a couple of reasons. Um, this isn't that necessary here. However, it's cool because we get to choose if the type T is move assignable and this move assign doesn't throw, we will move it, and otherwise we'll copy it. And we have a similar approach if you want to return a unique pointer. So we are kind of flexible. We can return a unique pointer, or we can return a reference. I mean, by reference, really, you can return it. So there is flexibility, and there's also wait pop and two wait pop functions that basically will wait for something to be in queue, which is also pretty amazing, I think. Probably the person that has joined my stream is having you, I guess. Now, so what are we going to do today? Yeah, so I was thinking that we have the server, and the server, there are two main functions. First function is that connects us, that connects the client, so this one, and the second one is that receives the message. And now I was thinking that, and then there's obviously a on connection closed. I'm thinking about handling it still. I am not 100% sure how I should handle that, but let's maybe discuss the design that I want to implement for this function. So the design I have in mind is that we will have some kind of collection. It will be most likely the queue that will grow in size, and and this queue will be accessed by both servers. Server will place new connections in the queue, and then there will be like a lobby maker class that will basically take this queue. We'll look at the queue and we'll say, let's look at the queue, right? It will say something like, that's interesting. It's like 5 players in the queue already. Let's make a lobby, and this then the lobby will be passed to a game conductor, and the game conductor will be a separate thread that basically conduct the game of poker for those players. Mm, now, now what I need to do, what I need to figure out is how to really incorporate this, because currently you have a condition variable for this data only for when data is um, it will scream, but it will signal a thread when the data is pushed in. And as a matter of fact, right now I realized something. Mm, where is that? Where is that push here? You don't have to return it. We should instead of returning, we should probably notify CV data CV notify one. Okay. Yeah, that looks better now. And so we should be notifying that the thread has put something in the queue. So that's cool. Now, I need to figure out how to notify that there is a certain amount of objects in the queue, and I don't really know how to do that yet. I'm thinking about maybe adding something here, like additional conditional variable, or maybe some kind of subscription. I'm not sure how to do this, and I'm not very happy about it. You see, the main problem is that if the size is 5, but we want to immediately call the lobby maker to make the queue. And the problem here is that we cannot change the size, that we must change the size and make lobby in the same lock scope, basically. Because if we check the size, release the lock, and then we try to access, let's say, 5 elements in the queue, and make the lobby, what will happen is that the size can change between those two calls. And God forbid the size changes in a way that some other entity takes an element out of this queue. Because then we have changed the size. Basically, the size is not coherent with the size that the lobby maker holds is not coherent with what's actually in the queue. But now that I think of it, I'm not sure whether there will be another entity. No, there will be another entity. Yeah, yeah. So as I said, this is the problem, and I don't know how to solve it yet. And I must think how to solve it because that's actually very. Mm. So it's called lobby. So we have a class lobby, and then we have a class game maker, or like game assembler that will be assembling the basically the people for the game, right? And then the lobby will contain the common utility thread safe queue of connections server connection. So we need to ensure that the server connection is copyable, constraints are satisfied. Yeah, we need to ensure that it's copyable. Um, let's call it actions. So we need to ensure that this is copyable. Well, I guess that's not the problem. Let's just define the constructors for that. Connection, const connection, other. So yeah, since the ID is const, I believe we won't be able to move it. So this will be always copied, which is I think not great. Maybe this is just wrong here. Mm, I will really think about that. What's your problem? Well, wait a second. Wait a second. Hmm. If this is a copy, now let's make a void operator for connection. Now, since I would kind of like to move it, um, I just must check the exact mechanism when I'm moving the weak pointer, like what happens. Um, I just presume that nothing really happens. As in nothing weird happens. It's just predictable. Um, I mean, yeah, move constructs moves a weak pointer instance from R into this. After this, R is empty and use count is 0. Yeah, and for the shared pointers, I guess the same. So this is a typical move behavior. Nothing to see here, I suppose. Shared pointer 10. A move constructor after and R is empty. And the stored pointer is null. The template over this contains a copy of the previous state of R. Um, R is empty and its stored pointer is null. I don't know why it doesn't refer to the block um, here, but yeah, it's kind of weird, I guess. But I just suppose that the block is also null pointer. What's the problem here? Cannot assign. Yeah, I don't think it should be const. Like, I mean, it's technically const, but making it const prevents us from copying it, and that's not the behavior. So I don't really know how to handle this. Maybe I should just. I really don't know how to handle this. This is an interesting case, I guess. Let me think. So I want to be have that copied. Okay. I want to have that copied. How many times will it be that I will be? Well, this doesn't have the default construct. So I believe that we will not be kind of creating it and assigning it later. We'll be just always like copy constructing it. We won't be copy assigning it per se. So I guess it can, but at the same time, I would really like to be movable. Mm, so maybe we can do a move constructor, and the connection won't be modified. I mean, that's tricky. Hmm. And I guess it's tricky like that. I don't really know how to handle the situation. I think that we can probably get away with just defining a move operator for this. I mean, now it should check out because now it has copies in place. So I don't understand why it's still. Um, what's your problem now? Maybe it's just not updated. Updated means built because right now it should work. I think. Oh wait, maybe it could. Constraints not satisfied for the class DSQ 50 server connection. Um, it's yeah, because it's no throw copy constructible, so we don't want to throw here anything. And let's just quickly paste the reality here. Yeah, those are no throws. So we can no accept this and no accept this, and we are Gucci. And now we should be. Yeah, now it's okay. Yeah, I forgot about the not true. I mean, let's make move operators and move constructor move operator, and because I don't really see why it wouldn't be why it would be bad. Let's say that connection other no accept. Um, why there is concurrency? I don't understand. Why is it in the dictionary, bro? Who is cooking? And the last one is well, ID is always ID is always copied, no matter what, right? Socket. Okay, what's your problem here? What's your problem? What? Wait. Hmm. No accept. Standard socket. Socket. Does not name. Oh yeah, that's true. Okay. So now we are moving it, and now we can construct also a move operator here. Move operator. Oh wait, I should remove the. Oh yeah, we remove the const, yeah, because it makes no sense to move a const object. Hmm. And this way we'll have kind of, I guess, more efficient behavior for this queue. Okay, that's awesome. Let's see live stream. Nobody is watching us. That's absolutely devastating. I understand how it's possible because I'm getting so much views on my past live streams, right? But when I'm streaming, nobody is watching that. So what's up with that? Like I don't understand that. Oh, okay. So we have the connections managed here. Now I have the lobby and his connections, and I don't know how to really do this well. I mean, hmm, But let's say, well, nevertheless, it needs to be filled somehow. Mm, we are aware of the problem of the size and the retrieval time versus the actual act on the information time for the queue, which is like, this is important. We are aware of that. How to act on that? Now, how to properly integrate? We need to. How do something like. mm, because if we could friend like a class here, mm, or to kind of expose data here, that would be so perfect, right? Or maybe instead, we should just specialize. I mean, specialize. We just write out um, the same thing for the for the waiting room collection. I mean, for the lobby here, right? To just implement lobby as this kind of reflexive queue and embed kind of and embed like how to describe it well and we could somehow embed the reaction to whenever this lobby exceeds certain size, because whenever the lobby exceeds certain size we need to bundle this, let's say, five elements, five objects, and ship them to some other object and erase them from a queue. So that's an operation that can be contained strictly in bounds of the queue. So let's say that I want to make a specialization, additional function to be a specialization, uh, additional function for a specialization. Is that even possible? Hmm. Let's check. Well, I think that instead of it, we'll just default to mm, taking this implementation and using it for lobby, actually, and kind of recreating the same interface for but in the lobby. And now we can just make it a server connection. I'm sorry. Mm, and this way it's not really templated. Yeah, we remove those. We don't want those. Okay, so it's not the best approach, I guess, because now we are kind of duplicating code, but I think that we will arrive at the correct solution here sooner than later. So now we are moving in the. Okay, so maybe let's make this using holy shit const equals server connection reference. Okay. Mm, try pop. Now we know that it's movable at this point, so I believe that we can just default to moving it because we know it's movable. So we can default to moving it. And now yeah, it's a connection. It's also and okay. So now I still don't understand what's his problem here. Like no matching member function. Wait on holy crap, man. I guess. What's the real problem though? Okay, push, try pop. Okay, bro, like, are you on crack or we are missing something? No matching member function. Oh, what? What do you mean no matching member function? I believe that there is something like that. Oh, because it's not a unique lock, yeah. Unique lock. Now it's okay. That's weird. That's weird. I didn't scream before that, but now it's okay. Okay, so there should also be. Okay, so now we have this interface copied here. Okay. What I said is that we need a way to establish when the size is when there's a correct size and basically give signal that there's a correct size and kind of make an endpoint that will copy the data. Hmm. Yeah, basically you need kind of like an endpoint that will copy the data and basically say, okay, send it. How to do this? This is a great question. Okay, I have an idea. But it's cursed. It's so cursed, as a matter of fact, that it's just cursed. Okay. So let's make some kind of static variable here. Static variable. Well, let's use it here. Hmm. And let's call it notify lobby maker. Probably agree to some kind of convention here. Notify lobby maker. Now this introduces hard coupling, which is not great. So we won't do that, I think. Instead, we will do something like notify. Um, I don't know. This is so hard, bro. I really don't know how to do this correctly. Um, because this variable is awaitable by just one thing, and I need someone else to subscribe to the like a different variable, basically. Hmm. I don't know how to do this, man. Holy shit. Hmm. Yeah, I think I'm going to read a book about this first. No, this. I don't know how to do this correctly. We'll do something like, okay, we'll just try to get it going. And the std condition variable, and let's call it maybe mm, lobby ready. And now maybe make it a public conditional variable. But then the mutex also has to be public, and this gets messy so quick. Okay, make those public. Make those primitives public. We'll worry later. Um, okay. So actually, what we can do is that we don't have to make the lobby ready. Let's just get the data CB. Um, and let's create a game assembler. Game assembler. What the game assembler will do, it will possess some kind of a reference to the lobby, and then it will have a function called run that will running while true. While true, it will um, create a unique log for lobbies mutex. It will lock it, and then when no other operation can be performed, it will check if hmm, it will check if um, Well, any kind of size, like, um, well, maybe then let's not make it, let's keep it private, but let's make it a friend plus. Um, yeah, and it's for declaration then. Okay, now if data, if lobby data size is equal to g maximum place in the lobby to something. Um, no, wait. What is the structure with conditional variable? Let's quickly revise that. Um, no, now we just need to wait. Now we just need to wait. You don't need to make an if. Um, CV, so make it a lobby data data CV wait on log, and now return lobby size is greater or equal g. Okay, and so this, okay, it screams at us. Lobby data size is still okay. It is good. So we are checking the size, and if it's greater, we're going to unblock. We are in the state where the lock is locked, when the mutex is locked. And what will, so we have the access control over the data. So what we can do is that we can um, pop free free of the data into some kind of a buffer with, connection. Um, okay, so um, for auto, um, oh, it's U8. Actually, this is stupid. It should be U8. It should be 64. Um, what we should do is that we should um, okay, and we're popping it. And afterwards we do we are we'll have like maybe a separate function for that. Create game. We'll be creating game. Yeah. And for now, create game is just going to nothing. Mm, Maybe like, well, we can just probably. I'm not really sure what we do. Why it's so fucking hard to code, bro? That is not the syntax. I'm looking fun doing things like that. I swear. Goofy. Um, okay, for now, let's not worry about correctness of this. Let's just make it print something like waiting to game. Um, at this point, we can unlock the mutex, I believe. Yeah, at this point, we can unlock a mutex. Um, and then we'll again try to lock it. Okay, I think that works kind of. Mm, so we have this with friends, the game maker, the game assembler, and then the game assembler kind of reaches into the lobby and is notified when the number of players of connections is greater than the amount, and those players are assembled into a full game. Sem- sem- Assembled into a game, and then they will be shipped to some other object that we will call maybe just a game. Mm, and yeah, they will probably like play a poker game, and afterwards they will be shipped again to a waiting room, the lobby. I mean, so lobby makes sense, I guess. Um, so now this holds a reference and intermediate buffers. Okay, server should hold a reference to lobby. Maybe server should actually have a unique pointer to a lobby. Well, I think that server should certainly outlive the lobby. Mm, but I'm not sure if the server is responsible for all this. No, it's there will be a server. There will be something on top of the server that will be storing both the server and the lobby. Yeah, so it will have only the casual. Okay, so let's create the lobby at this point. New file lobby cc and new file lobby h. Hmm. So, What's what? It is survive for all declarations. Friend, oh yeah, friend plus yeah, assembler. Um, we don't need log BC. Let's add it to the list. Um, Model, it's not a model, it's just here. Log B. Okay, it holds, it includes the server, and now we don't want, and now we somehow want the server to also include the log B, and well, how to do that properly? Log B only needs, um, log B only needs to know that there is a thing called server connection, so it's type. Um, I'll instantiate it, and then so how to not fucking scramble it together? Hmm. What does it need to know about this type? Does it need to collect a single function? Yeah, it calls. Okay, so we can just friend it. I think. Um. So I don't think maybe the server doesn't have to exactly know that the lobby exists ever. Um. Maybe let's counter it from the difference angle. Maybe let's forward declare like a class friend class lobby here, and then tell it, okay, you will have a pointer to this thing called lobby. You don't know what it is yet, and then those are obviously um, declarations, but actual like meat and potatoes um, will be in the server C, which can include lobby. Mm, it can include lobby.h, and it can have it can has it can have the definitions of those. So we are mainly concerned with this definition at this moment because we will be certainly concerned with the mm, definition on connection closed. I don't know how yet. Mm, but yeah. So the server on a new connection established. Mm, the connection. All right. Now we have a lobby. And why don't we have the lobby? What's going on? Oh, because yeah, it's funny. Um, Jesus Christ, can I please code? Okay, and we can push connection. Okay, that should do the trick. And then there's a totally separate entity that also okay, so instead of this we want to include lobby here. Lobby, okay. So now we are creating a lobby and the server. Actually, server can't exist without the lobby, so it will get it by reference. I mean, yeah, lobbies is extremely crucial here because what will react? I mean, can't live for the lobby. It makes no sense if it has no access to it. Like, yeah, it can live without it, but in my opinion, it makes no sense. If it hasn't got it. Hmm. But yeah, I think it's a pointer still. I think that there is a world where it doesn't have it. I think it's okay for it. Like it should have it without the Apple break. I mean, yeah, without it, it makes no sense. So let's make it a reference here. And at this point, I think we should provide a constructor here. Const server. I mean, it's not a const reference. Const server lobby lobby. But wait, if we are doing it like that, is it okay? Because yeah, it's mm, yeah, because I'm not sure if, but I think it's okay since we are calling it here. Um, so yeah, I guess it's okay. Lobby, lobby. Okay, so there is a problem. Lobby can't be copied. Yeah, so if lobby can't be copied, it must be a pointer, and it solves our problem. Wait a second. Okay. Um, so now if lobby will be pushing into the lobby. Hmm. I really believe that we should have this certified as always. Now, what's going on here? Lobby can okay, so it will have a pointer to lobby, and if lobby actually this is probably while lobby exists, we want to do this. If it doesn't exist, we can't do this at all. And it's a portion of this. Now, why doesn't it private member of server lobby? Okay, okay. Mm, friend class, okay. Class uh, game assembler, okay. And now we need to put namespace image. Okay. Yeah, that's awesome. So first we create lobby, we pass it to the server, and then we need to create private. Yeah, I think everything is private. but still, I think that the interface should kind of go here. With that. Okay, so in lobby, we have assemble game. The only thing that's public is actually the constructor, probably. Hmm, public game assembler will be um, what's going on? What's going on? Call implicit default uh, X. Let me see. What? I understand. Oh yeah. No, it call to implicit default constructor std array. Oh, because it doesn't have default. Hmm, that makes sense. That makes absolute sense. So we'll make it a vector. Um, Server connections. Uh, and we will the constructor we're going to reserve a proper amount for it. Reserve declaration. And then we will be pushing back like that. Mm, I need to read something first. I think this works. I think this works if mhm. Requirements given the following types. Yeah, I think this is okay. I think this is okay. Yeah, so okay, that's the build. That's a great finale here. Um, okay, I see what's the problem. Silly me. Let's go. Problem fixed. Lovely. Um, Now, if I have coded everything well, if that's one big if, we should be able to um, see the beautiful pop-up saying creating a game when three players join. And as a matter of fact, what we can further achieve is since we have the connections vector, we can iterate from iterate for each connection in intermediate buffer. We can do connection WebSocket send WebSocket log. Okay, yeah. std shirt pointer x WebSocket socket equals okay. If socket send. Oh, holy shit! What was that? Socket send joining the game. Okay, so now if everything is correct, we will receive joining the game signal on every client. Now that's one big if, and that's I hope it works. So here we are creating a server. Okay, it seems to be alive. And now it's time to create clients. Okay, we have established connection. That's awesome. Um, wait. So C client. We have established another connection, and now time for the final connection. And if this works, I'll be extremely happy. And it doesn't work. Well, that's awesome stuff. Why it doesn't work? Oh, because it should be equal. Actually. Yeah, I mean minor thing here. One more time. This time it will be faster. Um, okay. Server runs. Create one WebSocket. Create another client, and the magic didn't happen. That's not very well. Well, we have a bug somewhere. Um, let's keep this for testing. Okay, we have a bug. Not awesome. We need to find the bug. Hmm. Where to start, man? Actually, where to start with that? Hmm. Maybe let's start with making sure that everything is popped correctly. I mean, pushed correctly. So maybe let's start here. Yeah, we are pushing std um, print pushing pushed size, and we will get data size. And also we also let's be forward thinking here. We are doing this, but also let's okay, let's start with the simplest one. Let's start with the simplest one, just to kind of get feet wet. Okay, so it's interesting because pushing was never was never used here because I didn't rebuild the project. That's probably why. Hello to all three listeners or watchers. Hello to everybody in the stream. Nice having you. Currently I'm debugging a concurrent application and it's okay. So we have pushed something. That's lovely. So we know that the pushing works. Let's see on other clients. Pushed size 2, pushed size 3. Okay, now, I wonder. Let's copy this. If I run here one more client, what will happen? Pushed size 4. Okay, pushed size 4 means that the game assembler. Oh, yeah, snap! I know what happens. What happens is that we never run the game assembler. As a matter of fact, oh, assembler. We never run it, so I mean it's quite obvious. That we will never have a game assembled for us because we never run it. I'm such a dummy. Wait, we need to build it first. Okay. Run the server and start running the clients one by one. Create a client. Okay, client one. Create other client. Client two. Create another client. Creating a game. Joining the game. Let's go. Let's go. That's a small step for humanity. Humanity, but a big step. Small step for man, but a big step for humanity. And the push size is 1, which means that we have eliminated 3. Let's go. It works. It works, guys. It's awesome. We have a working game assembly here. So we are pushing into the lobby queue. Okay. Whenever a client joins, we are pushing him this connection into the lobby queue. And then when the lobby queue gets big enough, in this case, when the lobby queue contains 3 players, okay, the game assembler comes in, snatches those players, and says, "Okay, you 3, now you go and play a game," and it calls an assemble game function. Wonderful. That means that the game works. That means that the game, I mean, that this core feature works, which is awesome. That means that the last hour of my work basically was fruitful. Awesome progress, transformative impact, and somebody left. Yeah, that's actually not very nice. That somebody left right now because I kind of feel ecstatic. Mm. And we have another subscriber, by the way. Now we have 109 subscribers, which is crazy because yeah, I mean that's so cool. Like there are extra subscribers to my channel. I'm so happy about it. Yeah, so we have managed to do something actually that works, which is crazy because I'm really new to the concurrency. I'm trying to learn, and I mean we weren't caught in a deadlock. Yeah, man. Thank you, Simon. That's awesome. I appreciate the engagement here, and thank you for subscribing to my channel. That's really cool. Yeah, I mean, I'm really happy that this works. Now that we have completed this step, I wonder what I should do next because we basically have the lobby assembly working. Mm, Now, after after pushing this, after creating this game, right? After the game assembler creates a game, which basically what will happen does it that this intermediate buffer will be moved to a different section of the program, and this different section of the program we call something the game conductor. The game conductor will possess this member that will be basically a vector of connections. So the same thing as here. Um, yes, it will possess this collection, and let me think. And it will just conduct the game, right? It will start sending inputs and outputs to those players, like, yo, those are the cards that you were dealt. What's your move? What's your bet? Hmm. So this will be a separate section of the game, a huge separate section of the game. But after the game is concluded, the game conductor will return the players into the lobby. Mm. So I think that the next step is actually implementing like a simple game conductor that just takes in those players, waits like a couple of seconds, and returns those players to the lobby. Basically pushes them again into the lobby. And we will have this whole kind of loop finished. Yeah. Mm, as the main next logical step, but I think that will happen tomorrow because I want to go to sleep actually. I've coded a little bit today, and I'm happy that I've managed to code this thread safe queue because, as we can see, a lobby that is just a thread safe queue actually implements it correctly and works correct, which makes me happy. Small step for humanity, indeed. I mean, a small step for a human person, a big step for humanity, I guess. Yeah, I actually have this book on concurrency. I need to read it more thoroughly. Currently, I'm on this interesting topic of futures, which are basically like one-off tasks that can be completed. Um, oh, it's Rust. Wait a second. Yeah, futures, which are basically those singular tasks that can be waited for with SD async, like here. That's pretty cool. Maybe I'll like incorporate into the code, but we'll see what happens. Oh, somebody joined again. Well, unfortunately, that will be it for today. Have a good night or good day. It depends, I guess, on your time zone. And yeah, I'll be back tomorrow during similar hours. So yeah, thanks for the stream and goodbye.